This is problem number 5 for assessment number 3. In this problem, it says complete the following for f of x equals 3x if negative 5 is less than or equal to x less than or equal to negative 1, 5 if negative 1 less than x less than 1, and 6 minus x if 1 less than or equal to x less than or equal to 5. This is a piecewise function. It's got 3 different functions with 3 different domains. Now, it asks me in part A to determine the domain of f, part B, evaluate some numbers, part C, graph it, and then finally part D, let's see if f is continuous on its domain. So let's start with part A. They want the whole domain of f. So what is the whole domain of f? The whole domain of f is going to be from negative 5 up to negative 1, and then from negative 1 to 1, and then from 1 to 5, so it really goes from negative 5 all the way to 5. So the domain is negative 5, including negative 5, up to 5, including 5. Now part B, they want us to evaluate, I kind of move it down here, part B, they want us to evaluate f of negative 4. So f of negative 4 is going to equal, I take negative 4, look to see which piece of the domain is it in. Well, it's in the top piece. Right? Negative 4 is between negative 1 and negative 5. So I take 3 times the x value, which I have here, which is 3 times negative 4, and I get negative 12 for the solution for f of negative 4. F of 0 then, I look, where's 0 at in the domain? Well, it's not here, but it's between negative 1 and 1. So that says that that is 5, right? There's no x value to plug 0 into. So anytime you're between negative 1 and 1, it's just 5 for a solution. So we got 5 there. And then f of 5 is picking, is it in between here in this domain? No. We're going to check in between here. Nope. Down here, though, it is in that piece, so we do 6 minus 5, which is 1. I do want to point out, what if I say f of 6? Well, 6 is not in the domain, right? It's not in any of these pieces. So you would call this undefined. I just wanted to throw that piece in there so that you understand. If they ask you to plug in a number that's not in your domain, you just say undefined. It's not defined for the function. Part C, they want us to graph the function. So to graph the function, it's pretty easy. We're going to plug in the endpoints for the function into each piece and then just look at it from there. So I'm going to kind of just get a guesstimate on how big I need to make this graph by taking negative 5, plugging it in here. That gives you negative 15. So the y value for that will be negative 15. If I take 5 and plug it in here, I get 1. If I take 1 and plug it in there, I get 5. So I think 5 is kind of the highest we need to make this. So I'll make a coordinate plane. Down here, I'm going to label this. Let's go by, well, we can go by ones. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we'll do that same thing going up. 1, 2, 3, 4, 5. We'll go out 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we want 5 in each direction because negative 5 and 5. If I plug in negative 5 in here, I get negative 15. So I can come down here and mark negative 5, negative 15. If I plug in negative 1, I get negative 1 times 3. And when I plug in negative 1 times 3, I get negative 3. So I can plug in negative 1, negative 3 here. Now, because it says equals for both of those are closed dots. So I'm going to go ahead and connect those dots like so. For the middle one, I have negative 1. When I plug it in there, I just get 5. So at negative 1, I'm going to get this value of 5, but it's not defined there. So I'm going to put a 0 or a circle there. If I plug in 1, right, there's nothing to plug it into, I just get 5 as well, but it's not defined there, so I put an open dot. I connect those two, and this is a flat line at 5, right? Y equals 5. And now I'm going to plug in 1 for the bottom function. So I plug in 1, I get 6 minus 1, which is 5. So 1, 5, although it wasn't defined for the middle one, it is defined for the bottom function. So I actually fill that circle in and say it is defined. And then I plug 5 in here. 6 minus 5 gives you 1. So 5, 1 is part of the graph. And I connect those dots. So this is how you graph a piecewise function. You just plug in the endpoints into each of their functions, and then just graph them all in the same graph. For part D, it says, is f continuous on its domain? Well, continuous would mean if I put my pencil down and I drag it, I never pick it up. That's one way to think about continuous. You can see here that as I drag along, I jump y values to this different spot. And I have an open dot here, so it's not defined there either. So is f continuous on its domain? No, it's not.